In this example, we're going to look at factoring this quadratic trinomial where the a value or leading coefficient is not 1. This is the type of problem that presents a lot of issues for a lot of students. Maybe your number sense isn't quite as strong as you'd like it to be, and that could be part of it. I'm going to show how to do this a couple different ways. First of all, if I just show what I would do if I was approaching this problem, I trust my number sense. I probably would be able to guess and check this a lot faster than I could use what we call the AC method for factoring. So I'll go ahead and do that, and then I'll kind of slow it down and go into how we can turn this into a grouping problem and how to do it that way. So first off, I just wanted to try to factor this into two binomials. Looking at my first term of 6x squared, there's actually a couple different ways I could break that down. Maybe I could separate that as 6x times 1x, or maybe I could separate that as 3x times 2x. So this is one spot where guess and check maybe creates a little bit of an issue for people. If you don't pick right for this first separation, nothing else that you do after that is really going to be very successful. I'll go ahead and try 3x and 2x. Again, at this point in time, I don't know if that's correct or not. Let's see if I can make something work with the last term. So now I need to try to find ways to multiply to get negative 10 to fill in the second term in each binomial. So I need factors of negative 10 here and here. And when I check my distribution of the 3x times whatever I put here and the 2x times whatever I put there, those two products must add up to this positive 11x in the middle there with that. So I think by doing that, I think if I put plus 5 right here and minus 2 right there, positive 5 times negative 2 is in fact negative 10. And if I check and see what I end up with right there, 3x times 5 is 15x. Negative 2 times 2x is negative 4x. And when I go ahead and combine those terms, 15x and negative 4x, that does in fact make positive 11x. Again, I feel like my number sense is pretty strong. I know my multiplication facts very well, and I can quickly eliminate some choices and options for like different places in my head by saying, nah, that's too big, nah, that's too small, that'll never work. If you don't quite feel as confident with that, this may be really hard to do and figure out the right combination of numbers there. So I will go back and show how to do that a different way, but that is actually factored right there. So drop the eraser. If you didn't quite possess that number sense and you weren't quite sure how to do that problem that way and it got you a little bit lost, I can show you a much more systematic approach for doing that. We call it the AC method. You take the value of A and the value of C for this quadratic trinomial and you multiply those together. So the first thing I'm going to do is take 6 times negative 10. That's negative 60. And at that point in time, once I've found that number, negative 60, that product of the A times the C, now I'm going to look for factors of negative 60 that add up to positive 11. So if I just start listing ways to multiply to get negative 60, or just ways to get 60 in general, I could have 1 times 60, I could have 2 times 30, I could have 3 times 20, 4 times 15, 5 times 30, like that, 6 times 10. And again, I can make any one of those positive or negative. So now I'm just trying to see if I have any that are 11 apart and which one I would need to make positive and which one I would need to make negative. And I'm seeing right here with the 4 and 15, those have a difference of 11. If I make this 4 negative and that 15 positive, that combination right there would in fact add up to positive 11x. So now that I've figured that out, that's kind of like the critical thinking part of the problem. Now that I've determined that, what you're going to do is you're going to go back and rewrite the original problem. But instead of writing plus 11x, you're actually going to separate that one term into two terms using these two numbers. So I'm going to say minus 4x plus 15x minus 10. If you check and see, I didn't really change the value of anything here. I just changed the way it looked slightly. If I were to combine the like terms right there of negative 4x and positive 15x, I would still have positive 11x in the middle. But now that I've separated it this way, I'm going to just do a factoring by grouping problem. I'm going to group the first two terms together and pull out a greatest common factor. The greatest common factor between 6x squared and negative 4x is 2x. That would leave me with a 3x minus 2 left over. And now that I've done that, I'm going to go ahead and group second two terms together and pull out a greatest common factor there. I notice my sign pattern is the same, so I don't need to take out a negative or anything like that. It goes positive, negative, positive, negative. So if I go ahead and factor out the greatest common factor between 15x and negative 10, that would be 5. So I'm going to factor out a positive 5. And if I do that, if you look at what I'm left with a 3x minus 2 again. Get rid of this over here. I don't need that any longer. And you can see my two sets of parentheses match. Since those match, now it's like I'm visualizing this as one term and this as one term. What do those two terms have in common? Well, they have this quantity 3x minus 2 in common. So I will factor that out front. And then left over from this term would be the 2x. And left over from this term would be the plus 5. If you remember back or rewind the video back to what I had right there for the final answer when I just kind of did the guess and check and trusted my number sense that I could figure that out quickly, that's the same two linear factors that I had. I had 3x minus 2 and I had 2x plus 5. At least I hope, unless I made a mistake somewhere along the line. But that should be good. And either way, I've arrived at the same thing and I've completed the factoring.